So it looks like my recording didn't start, which really sucks. So I just started the recording right now. So welcome to those of you who have joined. We just completed question 10 from section 2.4, so you haven't missed so much. Question 10 basically is having us look at where the derivative is positive and where the negative, and where the second derivative is positive and negative. So we use concavity to determine whether where the second derivative is positive and negative. So you can see the negatives down here, and the positive is right there. Okay. All right, so we are going to move on to question 18 in section 2.4. So this is going to be, this is page 116. Okay, so we're asked to sketch a graph of a continuous function with the following properties. Prime of x is greater than 0 for all x. And f double prime x less than 0 for x is less than 2, and the second derivative. Sorry, my f's are so wonky. I've been trying to switch those up. So this is f. Second derivative of x is positive, for x is greater than 2. So first thing I would do is sketch out a little graph thing, and I would say here is x is 2. Okay. So I know that it's gonna have to be greater than 0, so I'm just gonna kind of like, what I would do is just kind of like dot a line in there, and I would say, okay, so that's kind of gonna be my reminder that I have to always have x be greater than, or f of x be, or f prime of x be greater than 0, excuse me. So I always have to be moving upward, and then it's concave down. This is negative, so CC down. And this is positive, so CC up. So so I kind of sketched out like that little like dotted line there. But I also know that it has to be continuous, which means that I'm gonna have to move from CC from like being concave down to concave up without like breaking, kind of like I sketched out. So what I'm gonna do is I'm just gonna do a flat line, so my slope is gonna equal 0 at 2. And then draw like that. So that is one possible function. I just kind of like, I reminded myself I needed to be constantly moving up. So I'm checking, just double checking, f prime of x is always greater than 0, or I guess equal to 0 at this point. So I should probably something a little bit more like that. So that I don't end up with my axis. In addition, you can just kind of like move this up and down wherever you want it to go, because we don't really have any other parameters, so it could look like that. And it could look like that. As long as it's concave down before 2 and concave up after 2. So that is question 18. Are there any questions about 2.4? All right, I'll take that as a no, and let's move on to 2.5. So this is talking about marginal cost and revenue. And so basically what this whole section is doing is putting like into finance context derivatives. And because this is like help for business, I remember last semester, not everyone was business majors. In fact, most people were not business majors. So they found this chapter a little frustrating, but it's just kind of like a part of this, and it's a really nice like application of like what you guys have been learning. Okay, so let's start with problem 2, and we're on page 122. So problem 2, we have the function C of Q gives the cost in dollars to produce Q barrels of olive oil. What are the units of the marginal cost? And what is the practical meaning for the statement MC equals 3 for Q equals 100? What are the units? We have a guess in the chat for dollars per, I can't spell, per barrel, and that is correct. So for every like change in, like if we think of it as delta Y over delta X for changes in barrel, how is the cost going to change? So exactly. What about for part B? So we have the statement MC equals 3 and Q equals 100. I don't really like this lingo of MC. I know that it's like that's kind of what like this whole chapter is about, but I prefer to write it as C prime of Q, just because it's something that I think is easier to understand. So, what is this kind of referring to? Okay, so basically this is going to be the change in, this is change, right? We're calling this delta Y over delta X. So if X, or in this case Q, if Q goes up by 1, then we're expecting this, the cost, to go up by 3. So if 100 barrels costs so much, then 101 barrels will cost that much plus $3. So that extra barrel costs $3. Yes. Q a lot of the time, like especially in this context, just going to mean quantity. So it's like the quantity of barrels that you're generating or selling, or they're going to use Q a lot as the dependent variable in this type of problem. So yeah, so this is the function C of Q. So this can be, you know, whatever, but Q is here. So if I change the amount of barrels I make, I change the cost of making that many barrels. In this case of olive oil, but that kind of sentiment applies. Okay, let's do problem 6. Okay, so we have Q units of a product. A manufacturer's cost is C of Q dollars, and revenue R of Q dollars. With C of 500 equaling, I'm going to write down what I know. I knew that C of 500 equals 7,200, and R of 500 is equal to 94. And then I also know that marginal cost at that point is 15, and the marginal revenue is 20. Okay, so for this problem, basically what we need to do is establish, we're trying to find profit or loss. So we need an equation for profit. And so that is going to be the cost of making something. Actually, that's a lie. It's not going to start with the cost of making something. It's going to be the revenue made minus the cost of making it. So if I'm like doing my own like business thing and I make $100, but I had to invest $50 into it, my profit is only going to be $50. So basically that's what this equation is saying. In this case, we're asking for the profit or loss at Q is equal to 500. So finding P of 500 means that I need to get R of 500 minus C of 500, which is going to be these numbers here. So it'll be 9400 minus 72. And so that is going to be 22. Yep, exactly. This is part A. Okay, so part B is asking if production is increased from 500 to 501 units, approximately by how much does the profit change? And so that's kind of what asking for is like marginal profit, or how does P change? And we're asking that in a very small scenario. We're saying like we're going from 500 to 501. We're not going from like 500 to 7,000, say. So the reason that we can use these numbers is because we're using small numbers in like a local area that we know. Exactly. So this MP concept is going to be the change in revenue minus the change in cost. So the change in revenue is going to be $20, so it's going up $20. To make like the revenue you gain is going up $20 if you make 501. On the other hand, you're also paying $15 more, so your net profit gain is going to be $5. And that is problem 6. Yeah, you guys know exactly what was going on. Okay, let's do problem 14. So, a company's cost of producing Q liters of a chemical is C of Q dollars. This quantity can be sold for R of Q dollars. Suppose C of 2,000 is equal to 59.30, and R of 2,000 is equal to 77.80. All right, so part A. What is the profit at a production level of 2,000? We just did that. That's going to be P is equal to R minus C. So P of 2,000 is equal to 77.80 minus 59.30. Get a calculator. All right. C minus. So this is going to be 1850. So P of 2,000. So if I make 2,000 units or 2,000 liters of this chemical, I'm going to make $1,850. Okay, so part B. If MC of 2000 equals 2.1, and MR of 2000 equals 2.5. Find NP, or change in profit with respect to quantity, or the derivative of the profit. From 2000 to 2001. Should the company increase or decrease its production when it's sitting at 2,000 liters? Okay, so we're going to do the exact same thing we did in the other problem. We're going to say that MP is equal to MR minus MC. And we're actually, I think I'm just going to double up here, got problem C. And all it does is have different numbers. So we're going to use the same process to solve both of these. 2000 is equal to okay, so same process. We're just going to say that is equal to 2.5 minus 2.1, which is equal to 0.4. This, on the other hand, is going to be, do you see what I'm doing here? You're following along? Awesome. Okay. This is going to be negative 0.44. I can't add in my head. You'd think I'd be able to do that, but I'm really just a buffoon when it comes to addition. So I forgot a decimal point. So that's 4.5. It's off by 0.01. Okay, so this is a negative 0.045. So these are pretty similar in terms of like magnitude, but one of them is positive and one of them is negative. So the next part of answering this question is saying, should the company increase or decrease production? In the first case, which is part B, should we increase or decrease? And why? Thoughts? Go ahead, put it in the chat box. Yes. We're increasing because we're making money. Our profit is going to go up if we increase. If we move from 2000 to 2001, we're making money. And exactly. And so we're losing money if we move that same distance So if we make more stuff, we're losing more money, and we don't want to do that. So we're going to decrease until we can maximize our profit. So we're looking for a point where our profit can be as high as it will be without losing profit on making more stuff. Coolio. Okie dokies. That's really all I have for 2.5. Do you guys have any questions about any of these problems? It's basically the exact same stuff that you've all been doing, but now with some different names, and it's like applications. There you go. It's like, it's a very practical thing. Like, you're very much like getting to work with the material and be like, yes, like I can see it. So it's like, it's a really handy dandy section in there. Okie dokies. Would you guys like to do some of the focus on theory? You guys did that this week, right? Okay, so the dealio with this is we're doing limits. And this is like very, very important for understanding like what's happening conceptually. Excuse me.
Very good.
I remember in my calculus class, when I was learning calculus, we like didn't even like start doing anything. We just started talking about limits, and we talked about limits for like a month. I don't know how my teacher did that for so long, but he just talked about limits for forever because it was like such an integral part of like understanding like how like calculus came to be. So the focus on theory in this section is like very important. We're going to start by doing problem 2, which is basically labeling a graph. And it's going to be a process, or at least it was last semester. Let's see if we can do this semester because there's a lot of just like things to label. Okay. And so this is the function f of x. All right. So we are going to be labeling a bunch of stuff. Oh, we are on page 135. So I'm going to start with A, which is labeling A plus H. Okay. So, do we have H marked down? Oh, we can just pick any H with H being greater than 0. Cool. This is what I'll call that then. I'll make it big. So this green line is A plus H, which would make this yellow part H, right? Because this distance, oops, this distance we know is A, because it goes to point A from 0 to point A. And then we have H, and then we have A plus H. So there we kind of started labeling our bottom there. Okay, next we have F of A. Okay, so where do you think that's going to be? So we have this function, we have this, A is going to go up to about right here. So F of A is going to be right here. I have A too far. I'm going to move A. I know, I'm so sorry. I'm moving A because I want to be able to draw something very clearly that I have in my mind, and I can't do it right there. So I'm moving A little bit to the left. Which means H is longer, but nothing else has changed. Okay, so now F of A is way up here. So here's F of A. And that is going to be like a Y distance, because we're not looking for like a point. We're not looking for the point A, comma, F of A. So this is that point. What we're looking for is the distance Y in the Y direction that F of A is. So that is going to be this really ugly line that I'm drawing right now. So this is F of A. So we go from 0 to all the way up to f of A. So I'm going to erase this dot real quick. Okay. Next, we need to label f of A plus h. So where is that going to be? Not quite. Basically, we're going to look at this as like a single x value. And so we're going to say, like, here is my A, and here is my length h. So my A plus h is going to be right here, right? So this is my point A plus h. So this is my point f, or this is my point A plus h. Comma f of A plus h. So my y distance is actually just going to be this chunk right here. Does that make sense? Are we all on board with that? Yes, no, maybe so. Okay, I'm not hearing any objections, so I'm going to keep going. Next, we are looking for, we don't really know. I don't really think it matters. If I kept drawing it, it could be doing some cool stuff, but I didn't keep drawing it, and I'm really only interested in this section, right, like right here. So, yeah, it could do all sorts of funky things after. It could not be zeroed. I could go, but I'm only looking at this section right here because I'm kind of like focusing in on it because I'm looking for a derivative. So that means kind of like getting in like very small areas. Does that make sense? Like, tell me if I'm being unclear because this is like important stuff to be on board with. Okay. So part E is going to be f of A plus h minus f of A. So that's going to be this region right here, right? This area that's
Baby still funkin'?
this area here that's like the difference between f of A plus h and f of A. So I'm going to kind of like extrapolate this out a little bit. So it's going to look like this. Okay. All right. So I'm going to erase this red line over here just because I'm trying to keep my area clean enough that it's like legible. Finally, we're just going to try to put together the quantity f of A plus h minus f of A over h. Like, what does that represent? You know, that's a good question. And I'm sure there's a good answer out there. I'm not really prepared to give it to you. I also think it's kind of funny the way that that was like done and written. For those listening in, he asks, like, if you're subtracting f of A, why is like f of A like included in here? Is that what you're asking? Yeah. So like, why Like, why isn't it like this tiny value minus this big value, and it's going to be a negative number, and it's going to be way down there? Because it's not convenient at this point is the best answer I have right now, which is a really bad answer, and I'm so sorry. But there's got to be a reason. Oh, okay. If you hang on with me for like a hot sec, I might be able to answer your question in a better way. So let me finish this, and then we're gonna talk about that. Coolio. All right. So so let's just quick label again. I'm gonna move my H line. I'm gonna label it like this. So we have this f of a plus h minus f of a divided by this h. So basically what I'm going to do is I'm trying to pick a decent color for this, but I've used up all of my decent colors. So we're just going to do light blue, I guess. The line between these points. And so this is f of a plus h minus f of a divided by h. Right? Because this is kind of like, this is rise over run. This is just like the slope between point A and point A plus h. Okay. Are we cool with this like assessment of what is going on in this picture? We're all on the same page? Nobody's saying anything in the chat box. Please ask questions if we're not on the same page. You don't like it, but you understand it. Okay, how about this? So maybe I drew it wonky the way that it is, but at the same time, is the slope positive or negative? It's going to be negative, which implies that f of a is larger than f of a plus h, right? Because if we're looking up here, in order for this top part to be negative, because we said that h is going to be greater than 0. That was one of the conditions of the way that we drew this. So that means that f of a has to be greater than f of a plus h, right? Which makes sense, which like it goes with the way that we drew it. If I were to draw something else, so I'm going to clear this drawing and like just a sec, give you guys like a couple more seconds. So if we were to draw something that looked like this, and this was point A, and this is A plus H. So here is H. Here is f of A. And let's see what color here. F of A plus H. And then I'm sorry for the drawing being like a little off. But if it has a positive slope, you're okay with it, right? Because then this is f of A plus H minus f of A. So the only reason we drew the red like it was in that last section was because we were trying to visualize it better, but it was negative. It was negative because f of a was larger. But in this instance, because f of a is smaller than f of a plus h, we have a positive slope, and like this is kind of what it's going to look like. And everything makes like a little bit more sense in the way that you look at it. Does that help, like, being okay with it? It's just the way that, like, it was drawn in order to kind of, like, better understand, like, why I drew the line like it was, but it was negative because that line was negative. It was a negative slope. The slope was negative. Everything was negative. Okay. Awesome. I'm glad. All right. So, let's do some questions on continuity. Let's start with question 14. Let's also do question 16. Is 14 continuous? Between 0 and 2. Yes. What about 16? Nope. Because there's that jump there at 1. What about if we're using the same graph from 16, but I'm asking this question? Is it continuous then? So we have this graph. Looks like this. And so we have this break up here at 1. Yep, exactly. So this is going to be continuous. Because if here is 0.75, then all I'm looking at, it's a good habit to just kind of get into this and saying, like, here is my interval. I am only going to be looking at this chunk. It's like I'm cutting the graph out and I'm only looking at this. So I'm not even considering this. This area is continuous. Cool. All right. So let's do a derivative by hand. You guys, this is the adventurous part. I'm taking derivatives. I promise you this is not what all derivatives will be like. It's just, it's so intense. It's very labor intensive. Okay. So let's find this derivative. We know that f prime of x is equal to the limit of f of a plus h minus f of a over h when h is approaching 0. So conceptually what this looks like, right, is if I had that graph from earlier and I had this slope and it was, you know, it was that and it was not very accurate. But then I said, okay, what if my h was smaller? And so then my slope looked like this and it was more accurate. And then I said, what if my h was even smaller? And it just kept getting more and more accurate the smaller h got. So eventually, I would, like, theoretically hit a point where h is equal to 0, or a plus h equals a, right? So that's kind of the point that we're doing. But the idea is that when you're taking a limit, is that h gets very, very, very close to 0. So h might be very, very small, but it never is 0. So you can still divide by it. And that's just kind of like a nifty trick that mathematicians like to do. So if h is very close to 0, but never 0. I think one of the examples my professor gave that was a really funny visualization was he stood in the middle of the classroom, and he was facing like one of the walls, and he said, I'm going to cut the distance between me and the wall in half every time. So he like walked like halfway to the wall, and he's like, okay, so I cut it in half, and I'm going to do it again. And so we did it again. And so the intervals got like proceedingly smaller, like each half was much smaller than the last one. And he like eventually was just standing with his face on the wall, and he was like, no, theoretically I should be able to just continue to half my distance. Physically, like that wasn't like possible at that point. But like theoretically, you should be able to get very close to 0 distance away from the wall or touching the wall without ever actually reaching that by cutting in half. Same reason why it's like dividing, like basically it was like a line. And so I cut it in half, and then I cut that in half, and then I cut that in half, and then I cut that in half. And I, by dividing by 2, am never going to equal 0. And so that is kind of the concept of this limit. And that's the reason that we're doing this like we are. So I don't know if that might have like helped you visualize what the heck is going on, but we are given a function and we're given that function x minus x squared. So f of x is equal to x minus x squared. My tablet isn't tracking very well. Oofda. Okay. So basically what I'm going to do is I'm going to go ahead and I'm going to put in so we're not going to call this, we're going to call this x instead of a. And we're going to put in this equation. So we're going to say that this okay, what I'm going to do is, there's too many x's, in my opinion. Let's do it like this. Do you guys mind if I switch up that variable a little bit? You want to do t. So basically what I'm going to do is I'm going to say sorry about my f's. F t is equal to f of x plus h. So I'm going to say that x plus h is equal to t. And so basically what I'm doing is saying that wherever there is an x, I'm going to put x plus h in this equation. So I'm going to start by writing f prime of x is equal to the limit as h goes to 0 of x plus h plus x plus h squared. Okay, so I'm going to take these t's out now because they're really pointless. But basically there were 2 x's that were kind of referring to different things. And that's kind of why I wanted to clarify, like by switching one of them up. And so now x is just going to equal x. So this is going to be f of x, which is going to be minus, is that plus or minus? Let me check. That is minus. So this, I missed a minus sign. So minus x plus x squared, because I'm going to distribute that minus sign. Actually, yeah, I'll just leave it like that. And so all of this is going to be over h. Okay. So let's simplify some of this. We have the limit of h going to 0. Wait, okay, first, is everyone okay with what just happened? Putting this equation into here. Okay, ignore the t's. The t's were stupid. The t's were really stupid. So if I had just like a number plus another number in here, I theoretically could just add them and then take the that number, right? So if I had f of 2 plus 3, I could just do f of 5. But because I don't know exactly what these numbers are, I have to write them with the plus sign still in that equation. So ignore everything I said about the t's. I'm so sorry that existed. And I hope it doesn't confuse people. Is everybody okay with how we reached the point that we're at? Okay, so basically what we did is we said that this equation is true. This is like the equation we're trying to take the derivative of. And this is the way that we know that we can take derivatives. Which means that we need to take the limit of, as h goes to 0, of f of x plus h. Okay, I'm going to clear this. We're going to start over. So this is how we take derivatives by hand. And so I have my f here, and that's going to be x minus x squared, right? So basically what I'm doing is I'm saying that what if I had f of x plus h? Then that would be, but wherever there's an x, I'm going to put an x plus h now, because that's going to be my variable. So I'm going to say that that's x plus h minus, and then I'm going to put another one there, x plus h squared. So f of x plus h is equal to these two. So I'm going to put that in where it belongs. So I'm going to say limit of h as it goes to 0. And then instead of having x plus h, f of x plus h, I'm just going to write x plus h minus x plus h squared. Minus, and then f of x, we already said was going to be this here, right? So I'm just going to say, instead of f of x, I want to write this part, because this part is going to like allow me to solve this. So it's going to be x minus x squared. And then all of that is going to be over h. And then from here, I can start simplifying. So the goal is to find things that are equal to one another and then use those equalities to like eventually keep it becoming more and more simple. Does that make sense? Awesome. Okay. All right. So then we're going to simplify it. We're going to say the limit of h as it goes to 0. This is going to be plus h minus x squared plus 2xh plus h squared. So that's what this is. Minus, and so this is in parentheses, so minus x plus x squared all over h. So now because I've got addition, I can get rid of these parentheses. So I'm going to say when of h goes to 0, x plus h minus, I have to distribute this minus sign. So x squared minus 2xh minus h squared minus x plus x squared. All right, all of that over h. Now I'm going to start deleting some stuff. I have a positive x squared and a negative x squared. So those are going to go bye-bye. I have a negative x and a positive x. Goodbye. So I'm going to end up with the limit as h goes to 0 of h minus 2xh minus h squared divided by h. You'll notice that there's h's in every single one of these terms. And so I can factor out an h. I can say this is h times 1 minus 2x minus h divided by h. Now, given that h does not equal 0, because it cannot divide by 0, we can cancel these out. Okay, so that leaves us with lim as h goes to 0 of 1 minus 2x minus h. So if h is very, 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 very small, we're going to say, we don't really care about it. It's going to equal 0. So here, we're going to say it equals 0 because we don't care about it. It's too small to care about, but it's not so small that it's 0, right? We're like on that fine line between it's so small we can't care about it, but it's not so small that we really like are getting like problems caused by it. So that leaves us with the function 1 minus 2x. Let me move the checkbox really fast. So this whole shindig was going down because we said that f prime of x is equal to this. And so we found what this whole thing was equal to. So f prime of x is equal to 1 minus 2x, which is something that you'll be able to verify next week in a very, very simple way. But as of this week, this is how you know how to find it. And that's doing the whole thing by hand. So the derivative of f of x is equal to x minus x squared is equal to f prime of x is 1 minus 2x. And that's the derivative. Thoughts, comments, concerns? I know that this part is like, seriously, and what are we doing here? But yeah, no, don't worry. This section is like, this whole like do it by hand algebra until your brain rots thing is like over so quickly. You'll be taking derivatives next week like nobody's business. It's going to be great. And you're going to forget that this ever happened to you. But for right now, we do need to understand. And so the point of it becoming very, very small is this, like, so if A is here and H is here, and then no, wait, H is here, and then no, wait, H is here. And so you want H to A plus H to approximately equal A, but A plus H cannot actually equal A, is the point. So basically H cannot actually be 0, but you want to get as close to 0 as you can get. Okay, I'm going to stop talking about this now. That's taking a derivative by hand. Love this. No, I don't. I'm not seeing any questions. Please feel free to ask. If not, then we're probably going to wrap this up for the night. All right. So sorry about the cutoff recording, and sorry about last week. I did the whole recording, and it turns out that it got corrupted on my computer, which happens sometimes, and I hope it doesn't happen again. If not, I'm gonna have to seriously start looking at some things. But this is the end of chapter 2. This class is chugging right along. Okay. Well, you guys all have a great night. And email me questions or post them on my GSG announcements or anything like that. And I can answer them in the next session. Okie dokies.